Here in the city of Ludwigsburg, just north of Stuttgart, the energy from over 1,000 solar collectors flows into a district heating network. We're pleased with the system. It delivers between 5,000 and 6,500 megawatt hours per year. On the outskirts of Leipzig, Germany's largest solar thermal plant is being built. We will feed the heat from the solar thermal system directly into the district heating pipeline, and from there we will distribute the heat throughout the district heating network. And 2 municipalities outside of Dortmund are already completely climate neutral thanks to a solar-powered heating network. Look how our village has changed. It's in a good state of repair. Older houses are being fixed up. A solar thermal plant feeds its heat into a 6-kilometer-long local heating network and supplies the villages of Neuerkirch and Külz. The neighboring wind farms on municipal land play an important role in financing this climate-neutral infrastructure. The rental income was reinvested in the heat supply in accordance with a council resolution. The money from the wind turbines has to flow back into the village, and we want to make sure this gets implemented. Construction of the solar plant and the district heating network was funded not only through income generated by the wind farm, subsidies also helped to make it possible. The collectors cover an area of around 3,500 square meters. You can really touch it. It's cold. It also cleans itself pretty much automatically. You have to help it out every few years. How much energy does it provide of the required heat? About 20% annually. The vacuum tube collectors not only supply a fifth of the energy required for the heating network, there is also abundant life under and next to the roughly 300 collectors. There's so many small animals here that weren't really here in the past, because it was always mowed or grazed. There are snails, there are mice, there are even birds nesting here. So we haven't actually taken anything away from nature, and maybe even done a bit of good. In order to ensure that none of the heat produced in summer is lost, there are 2 large water storage tanks, each with a capacity of 60,000 liters. Next to them, wood chips are stored. These are burned in 2 large boilers in the adjacent energy center and provide the rest of the energy. The wood-fired combined heat and power plant and the solar thermal system supply around 2/3 of the houses in the 2 villages with heat via the district heating network. This climate-neutral infrastructure has led to property values rising as a result. Especially the older houses are being renovated and revitalized. Sometimes an old house comes up on the market, I hadn't even heard it was up for sale, and it was sold. Many of the older houses here are historic structures, well over 100 years old. The climate-neutral local heating network simplifies energy-efficient renovation. It's very important for the owners because some of the houses were built with clay on the inside or with slate. You can't install insulation there. And the local heating gives them a big advantage compared to if they heat with oil. The whole thing is much cheaper. When the heating pipes were laid, local politicians thought ahead and also had fiber optic cables laid in the open trenches. When the local heating network was being built, we installed a fiber optic connection in every house, regardless of whether it was residential or not. And that was a great idea. How many people do you think really work from home here? Quite a lot. Like Lisa Steinhaus, for example. She is a mathematician who lives with her husband Hendrik and their son Lasse in a house built in 1954, which they are still renovating. Thanks to the fast internet, Lisa Steinhaus works from home from an institute that uses AI to analyze large amounts of data.
I ended up here in a roundabout way. I feel very much at home, though, partly because of the buildings and the local heating network. You just have to make the connection, and you don't have to build another heating system in your basement. There's very little on the housing market, and when something comes up, it's gone very quickly.
Young families in particular are drawn to this idyllic village with fiber optic and district heating connections. There are a lot of small children here, that's great. In the neighboring village of Külz as well. We really need to build a kindergarten now. We have almost 80 children that are of kindergarten age. Climate neutral energy plus digitalization? Hey, your village has arrived in the 21st century. You could say that. Our buildings are old here, and yet we are brand new and very young on the inside. The population in both villages has grown by around a quarter in recent years. Neuerkirch and Külz have a bright future. And a word about us. Renewables.film conveys the energy transition through journalistic films. We would be grateful for your support so that science and technology documentaries of high quality can continue to be produced. You can find more information under the video in the description. The future is looking rosy in Leipzig as well. The population has been growing continuously for over 20 years. And the city's residents will also need a climate-neutral heat supply in the future. Germany's largest plant is currently being built on the outskirts of Leipzig, roughly 7 kilometers from the city center. Heat from the plant will flow into the city's district heating network. This network supplies several thousand households. Eric Jelinek is responsible for construction of the site. Yes, time is of the essence, but there's a lot of work that can be done off-site. We can't do everything at the same time and have too much going on, otherwise we get in each other's way. We'll need about 2 years from start to finish. Machines ram steel profiles into the ground. The site covers an area of 65,000 square meters. Workers erect 800 so-called tables. They form the foundation for 13,000 solar modules. In addition, technicians are welding together pipes with a total length of over 45 kilometers. When the site is finished, more than 100,000 vacuum tubes will use solar energy very efficiently. This is a double-walled glass tube with a vacuum in between. It's like a thermos bottle with very good thermal insulation, which is what we are looking for here. When the sun shines, the collectors heat up. Then the water that flows through them heats up. When the water has flowed through several of these collectors, we collect it yet again. At that point, it has reached the temperature the district heating requires, and then we send it back again. From there, into the entire district heating network. When everything is finished and the protective film covering the collectors has been removed, the entire system will have a thermal output of 41 megawatts. This heat will then flow into the city district heating network. Wind turbines were also considered for the site in Leipzig, but ended up not being a viable alternative. There are people living in the immediate vicinity. You can see the apartment buildings a bit in the background over there. So you can't just put a huge wind turbine here. That would create considerable problems for the people who live around here. Instead of a large solar thermal system, there would have been space for a wind turbine on the site. The wind power could have been used to generate heat. Wind, however, would only supply around half as much green energy per year as the solar thermal system. And as it is, the installation of a wind turbine would not have been possible due to the residential area nearby. Engineers can, however, install photovoltaic panels here. These produce electricity rather than hot water with the help of solar energy. This green electricity can then be used to operate a large heat pump. Renewable energy is in constant use. However, the higher the temperature necessary for heating, the more electricity the heat pump requires. The district heating pipes in Leipzig require water to be heated to around 100 degrees Celsius, far more than a heating system in a detached house. Due to such a high temperature, the combination of solar cells with a heat pump would not have been very efficient at this location. With a solar thermal system like this one here, we have an efficiency rate of between 40 and 60%. This makes us much more efficient. We can use the space better. Leipzig has more than 600,000 inhabitants. The district heating network covers about a third of the total demand for heat here. Energy is never lost, not even when the solar thermal system is running at full capacity at the height of summer, because there is always a demand for warm water in such a large network. If we want to generate heat in the summer, or if heat is needed, as is the case here, we can do this most efficiently with solar thermal energy. Due to the proximity of the city's heating network, there is almost no loss during transmission. Since there is always a demand for heat, even at the height of summer, the solar thermal system is the best way for the engineers to use as much of the renewable energy available on the site as possible. During construction, however, energy efficiency is not the only priority. There is another important detail, that there are at least 80 centimeters between the ground and the modules. This area will become a pasture for sheep. It makes it easier to keep the grass in check. Then we don't have to mow as often, which is part of the ecological maintenance concept. Surface sealing will be held to a minimum. A separate nature conservation concept provides for the planting of hedges and fruit trees. Sheep will graze on the meadows between and below the modules. Just how green a large solar thermal plant can become can already be seen in southern Germany in the state of Baden-Württemberg. Ludwigsburg and Kornwestheim are neighboring towns that jointly operate a large solar thermal plant. There are over 1,000 collectors on an area of around 15,000 square meters. This stretch of land has become a haven for lizards. You can find them all around the house, even under the collectors. They've clearly multiplied. The whole thing was a win-win situation, both for the lizards and for us as a municipal utility. The heat is transferred to the district heating network of the cities of Ludwigsburg and Kornwestheim in a control center directly next to the large solar thermal plant. The heat in the pipes is around 70 degrees Celsius. We have a flat plate collector here. This is actually an aluminum frame with a safety glass pane on the front that protects the collector. An absorber plate is underneath it. That's the blue you can see. This shiny dark blue. That's what absorbs the radiation. We're very happy with the system. It delivers between 5,000 to 6.5 thousand megawatt hours per year. The operating costs are very low. It's a low maintenance system. The heat is transferred to the district heating network of the cities of Ludwigsburg and Kornwestheim in a control center, directly next to the large solar thermal system. The heat in the pipes is around 70 degrees Celsius in the summer and 90 degrees Celsius in winter. So far, over 1,000 buildings have been connected. And the demand for district heating is high. Everyone wants district heating, at least that's how it feels. We're being overrun with requests, which has to do with all the attention it is getting in the press. Everyone wants it. We're having difficulties keeping up, in fact, being able to meet the requests and get people connected. The district heating network in Ludwigsburg and Kornwestheim will undergo major expansion over the next few years. During the summer, the collectors actually supply more heat than is needed for hot water. To ensure that none of the climate-neutrally produced energy is lost here, heat is stored temporarily in a 2 million-liter water tank. You can see here the large buffer storage tank, which is used both for the solar heat as a buffer and for the wood energy that is created, meaning the energy from biomass, such as the wood chip plant behind us. The solar thermal system supplies about 6% of the energy needed per year in the district heating network. Additional heat suppliers are therefore needed. That is why there is a large wood-fired power plant right next to the storage facility. The plant burns wood from so-called landscape conservation measures. In other words, when trees and bushes are trimmed or green spaces are cut back. The wood complements the solar heat very well. This means that we can do upkeep repairs on the wood-fired plant for 3 to 4 months. As a rule, we extend the inspection period because we now have the solar system which supplies most of the heat in the summer. And the system then runs really well in winter operation. The solar thermal system supplies a large proportion of the heat required by the grid in summer. The wood-fired plant can therefore be switched off. It only needs to run continuously during the cold season. This reduces maintenance costs of the wood-fired plant. The solar thermal system therefore increases efficiency when using other renewable energy sources. Roughly half of the district heating produced in the cities of Ludwigsburg and Kornwestheim is climate neutral. The Swabian engineers want to use other environmental sources, such as the nearby Neckar River, to reach 100% decarbonization. It's our goal to have decarbonized everything by 2035. With a mix of sources, we will be able to do it here in Ludwigsburg. We are also relying on heat pumps, large heat pumps. The river water heat pump will make a significant contribution here. Behind us we can see the Neckar River. That will probably be combined with sewage water heat pumps. Frankly, we are relying on many different technologies in order to decarbonize the last 50%. In order for heating grids to become climate neutral in Germany, they need to be converted. Well over 50% of electricity from renewable energy sources already flows through the German electricity grid. However, Germany's district heating grids do not even use 20% renewables. Yet solar heat can be generated in Germany just as cheaply as solar power, for around 5 cents per kilowatt hour. Conversion work has already begun in Leipzig. Once completed, Germany's largest solar thermal plant will go into operation here. Further solar thermal plants are also planned to supply the city's large heating network. If there is sufficient space not far from an existing or future heating network, solar thermal energy is an efficient source of renewable energy and can make an important contribution to the climate-neutral heat supply of German cities.